Example 2 does the same thing, but now introduces variables. Okay? And it also revisits this idea saying, when is it defined? So first of all, we have to figure out when it's defined, and then we have to expand. Okay? Expand and simplify. In mathematics, expand means get rid of the brackets. That means you have to distribute, you have to FOIL, we need to get rid of those brackets. And then simplify, well, simplify means a whole bunch of things. For radicals, it means combine like radicals and write your radical in as a mixed radical in lowest terms. So first of all, for defined, our variable inside is b. Can b be positive? Can b be negative? No. Can b be 0? So b cannot be negative, therefore it's defined when b is bigger than or equal to 0. To simplify, multiplying this out, 7 times 3, 21. 7 times a negative 5, negative 35 root b. 2 root b times 3, multiply the numbers in front, 2 times 3 is 6. The only radical we have is the root b. And finally, 2 root b's minus 5 root b's will be minus 10 root b squared. Because b times b is b squared. Do we have any like terms? Yes. These are like terms. They can be put together. Negative 35 plus 6 will be negative 29 root b. Can I simplify the square root of b squared? Absolutely. It becomes negative 10 b, because the square root and the squared cancel each other out, and when we take the square root of a variable, we often included absolute value bars. But if you look down at the bottom of the page where they have the answer, the answer in this case doesn't have the absolute value bars. Any idea why? It doesn't feel like putting them? Because we defined it already as only being positive. It never will be negative, so the absolute value bars aren't necessary. Whew, how's that for complicated? If you left them, would I mark it wrong? No. Part B is just long. Did it open up into, there we go. So in part B, the first part, we need to multiply these together. If you recognize that they're conjugates, you could maybe do a shortcut. If you recognize that it's a difference of squares, you could do a shortcut. If not, you would have to multiply it all out. And so you would get 9 root x squared. Oh, I forgot to do where they're defined. Let's do that first. What about x? X have to be positive, negative, or both? Both. No, can't be negative. Has to be positive. What about y? Y has to be positive. Good. There. Now we can multiply these out. 3 times 3 is 9. Root x times root x will be root x squared. Negative 3 root xy. Well, you are not allowed to take a square root of a negative number, right? What's the square root of negative 5? Your calculator tells you error. So it's not possible with real numbers to take the square root of a negative number. So when something is defined is where it's possible. And so for the number system that we use, x has to be bigger than or equal to 0. Okay? There are some number systems out there where you're allowed to take square roots of negatives, but that's not, we don't do that in this course. You can set your calculator up to allow you to take square roots of negatives. So that, see if you can, what's the square root of negative 9? 3i. Okay, if you're allowed to take square roots of negatives, that's the answer. But then you have to use the, sometimes it's called the complex number system, sometimes it's called the imaginary number system. But I'm not going to play with your imaginations right now. For us, we can't do square roots of negatives, and we're just happy with that. Later on, if you want to see how the complex number system or the imaginary number system works, I'll let you know. Continuing to multiply this out, on the inside, root y times 3xy will be plus 3 root xy, and then root y times a minus root y will be minus root y squared. That's just the first one. The second one, you would have to FOIL as well. Be careful, because there is a negative sign there. So I'm going to put that negative sign there, and then I'm going to FOIL that out and put it all in brackets. The reason it needs to all go in brackets, because in the question, we're subtracting all of this. That's what that negative sign means out in front of there. And so whatever answer I get for that, I have to subtract it. And my guess is when we get to this quiz, well, let's see. I would say on average in past quizzes, this is a place where 80 to 90% of the class makes a mistake. You're aiming for 100% to make the mistake? Thanks. I really appreciate that. We're hoping that this class is less than that 80 to 90%, because I'm already throwing out the statistic to you. Let's see if you guys cannot make the common mistake. So since we're subtracting all of this, when I multiply this out or square it, and sometimes it's helpful to rewrite it out twice so that you know that you have to FOIL it. When I multiply that out, root x times root x will give me root x squared plus 5 root xy plus 5 root xy plus the square root, plus 5 times 5, 25 root y squared. It is so long. Now let's combine some like terms. First of all, these cancel out. 9 square root of x squared just becomes 9 absolute value of x, but you won't need those absolute values because x is already defined to be positive. But we'll put them there just to practice, minus absolute value of y. But you don't need those absolute values there because y is positive. Back to green, minus bracket. Bracket, let's simplify in here. What's the square root of x squared? Absolute value of x, 5xy plus 5xy, those are like terms. Root 10xy plus 25 absolute value of y. Now, since this question is only defined when x is bigger than or equal to 0 or y is bigger than or equal to 0, the absolute value bars are not needed. So this question is just 9x minus y. And the reason these brackets are important, where I said in the past 80% of students make the following mistake. They forget that they have to distribute the negative to all of them. Since you are subtracting all of this, you need to subtract all of this. In algebra, when you subtract more than one term, that negative goes to each item. And so we have minus x minus 10 root xy minus 25y. Do we have any like terms? Yes, we do. 9x minus x, 8x minus 10xy, and minus y minus 25y minus 26y. notice in the answer key, they have the order switched around a little bit. The order does not matter. However way you write your answers, because adding and subtracting doesn't matter the order. X plus y is the same as y plus x. Question number 8.